Welcome to Programming with Python session 9. Before we jump on to the actual content, please subscribe to Technolearnit YouTube channel so that you'll be getting daily quiz and also the content that we are using during these sessions. You can have free download options, you can download them, you can practice them, and you can become better programmer. All right. With that said, today's topic is lists, right? Let us get some background. What you see here is a classroom, right? So what if you want to store the marks of 60 students who are in UKG, right? If you have to store one value, you need to have one variable. Since you need to store 60 marks, right? Marks of 60 students, you need to technically have 60 variables. Is it practical to create all 60 variables in your program? Probably not. What if the number of students increases to 500? Sometimes you may want to store the marks of 500 students, meaning you need to have 500 variables in your program to deal with the situation. However, creating such huge number of variables in the program is impractical. That is where lists come into play. What is a list? List is a collection of multiple values stored in a single variable. Interestingly, list allows us to store multiple values stored in single variable. If you want to store the marks of 60 students, you can use list. List will have one name, however, it allows you to keep storing the values in that single variable and you can store multiple values. List is a built-in data structure in Python. It comes by default once you install Python, and so you can directly go ahead and use list in your program. List is a data structure that stores ordered collection of items or ordered collection of elements. I'll show you how you can treat list as an ordered collection of items practically in some time. Also keep in mind that list allows duplicate values to be stored within it. That means you can store the same number or the same element again and again in a list if required without any technical problem. You can also store items of different data types in a single list. Interestingly, if you want to store one integer and 10 floats and 15 boolean values with 10 string type of values, yes, list is an option for you, obviously. And a list is represented using square brackets, and the items within the list are separated by comma. That's what we're going to see very soon. And keep in mind that list is indexed. What is indexing and how does index help us to deal with elements in the list is what we are going to practically see in some time. And the most important one, lists are mutable. What do you mean by mutable? That means you can change the elements within a list if you want to change them. And whenever you want to change them, list allows you to change the elements that it holds within itself. All right, let us now get on to a practical code that illustrates all these properties of a list. So this is a syntax where a list can be defined, right? You see a square brackets appearing over there after equal to symbol assignment operator. Yes, of course. And every list will have some name. Here the name of the list, I mentioned it as list underscore name, and whatever elements that you want to store, whatever items you want to store within that list, are separated by comma and enclosed within square brackets. Alright, let us look at some practical examples. What if you want to store the marks of 4 students? Yes, list is an approach for you to deal with the situation. So here marks is what you see in statement 2 is the name of the list. 92, 89, 67 and 90 become the items of the list marks, and if you look at them they are separated by comma and enclosed within square brackets. This is how you can create a list in Python. Another example, what if you want to store the attendance of a class for a week of time, assuming that it is a 6 week of working days, right? Attendance here is a name of the list. 48 is the number of students attended on particular day, first day of the week. 45 is a attendance that you have taken on the second day of the week. Similarly, on the third day, you see 48 is a repeated value. As I said, list is a data structure that allows you to store repeated values. Here 48 is repeated and 49 is also repeated. This is how you can, if required, can store you can store duplicate values in a list. This is another list that you can see, and the elements are of type float. This is another list by name promoted, and each element within this list is of type boolean, true or false, right? Name is the name of this list on line number 6, and each element within this list is of type string. Abhi is a string class. Bindu is a string class type. Ravi is a string. Ram is a string. So you have stored string type of data in the list named name. And look at this carefully. This is also another list, and the name of this list is data. 92, which is of integer type, is the first element in this list. 40.5, which is a float, is a second element in this list. True, a boolean type, is another element in this list. Abhi, a string type, is another element within this list. So as you can see, a list can hold different types of data within itself. All right. So what is that we are going to have a look at, right? These are the things that we are going to closely look at practically during this session. Okay. For that, let us first go ahead and let me show you practically how to create a list. Okay. As you see, if you want to store some numbers is the name of the list, and you can store some numbers within that. And yes, now you can probably print the type of numbers. It says it is list type of class. If you have ABC is equal to 10, now if you print type of ABC, it just treats it as an integer because ABC is a variable name which refers to only one value, whereas numbers is a variable name which stores multiple values within it. So list is a data structure that allows you to store multiple values in the single variable name. And here numbers is a variable name. To be more precise, it is a list type of variable. And if you want to look at the type of numbers, it is nothing but list type of variable. All right. And what if you want to store cost? Cost of maybe gold um, in 4 consecutive days or whatever, right? So you can probably store something like this, right? Something like this. So you have stored the cost of gold or whatever um, for 3 days, right? Here also, if you look at the type of cost, it shows it as list type, right? So you know how to create a list of integer types. You also know how to create a list of float types. Now let us create a Boolean type of list like this. So say has attended is a name of the list, and you can probably store something, some Boolean values. So like this. Yes. Once again, print the type of has attended. You can see. Sorry about that. It was a typo. Sorry, that was printing the direct values of the list, but I was trying to print the type of this list, right? You can see has attended is also a list type of data structure, right? What if I want to store some strings? So you can say maybe the names of the students, right? Some names, some strings basically. Okay, we can also look for the type of names. It is also a list type of variable. This is how you can create lists of integers, lists of floats, lists of booleans, lists of strings. Interestingly, you can have different types of data within the same list. Okay, you want to store a string type as well, and one more Boolean type. As you see here, this is perfectly allowed, valid in Python. I can now print type of my data. You see, it is also a list. So, list is a data structure that allows you to store different types of data within it. And of course, you can also store same type of data within it. It's up to you. It is based on the need and the requirement that you have in hand. All right. This is all about how to create a list. What if I have to create an empty list? I can say, I can give any name, of course, and this is how I can create an empty list. Also, Let me go ahead and ask for the type of the variable empty list. Yes, of course, it is also of type class list. Okay, this is how you can create an empty list. Okay, the other way of creating a list is you can use list and you can specify the values that you want to store separated by comma like this. You see, my list is equal to here. My list is the name of the list, and the list is the keyword that you are using here, the name of the class in Python, right? And you have to use brackets, braces, right? And within that, you have to once again mention all the elements or the items that you want to store within that list within another bracket. Make sure you don't use square brackets in this syntax. Okay. If you are using list on the right hand side of assignment operator, then you should always use braces, not the square bracket. Okay. Again, you can probably print the type of my list and confirm that that is also of type class list. Yes, it is also of type class list. So these are different ways of creating different types of lists. Mixed types of lists, integer type of lists, or float type of lists, right? Boolean type of lists, and string type of lists, and empty lists, of course. And if you want to really use list explicitly on the right hand side, this is how you can use. So, right? This is how you can create the lists. Now, let us go back and look at the list cost. How do I know what this list contains? For that, you can use print directly and you can use the name of the list. See, the cost is a list, and you see all the elements within this list are printed here, separated by commas, also enclosed within square brackets. What if I print the list has attended, right? Has attended is another Boolean list. Let us see what it has. Yes, you can see all the values that we have stored in that. We are able to get them back. Similarly, I want to print the value stored in names list. Yes, these are all the names that you can see printed. Similarly, we have my data. There's another list. Sorry, uh, print my data. Yes, these are the values that I have stored in my data list. You see, it's the same order that it follows in the same order in which you have stored them. The same order it follows while you are retrieving the data back. That means it respects the order. So list is an ordered data structure. The meaning of this sentence is that the same order in which you have stored the values in it, the same order is maintained when you are retrieving the data back from the list. All right. Now, what is the other list you have? Empty list. Let us print empty list and see what happens. You can see there are no elements within this empty list, hence it just printed square brackets, meaning it is an empty list. All right. Now, finally, I'm going to print my list as well because I have constructed that my list in a different way. Yes, this is the same thing that you can use, the same syntax you can use. It's just something back. How do you print the value of a variable, integer type variable? Quite simple. No, you have to just mention the name of the variable. And in this case also, you just need to mention the name of the list along with print. So here the variable name is nothing but argument to print function, and it can print the elements from that list, all the elements from that list. This is about creating the list and printing. I covered first and second. Next, let us go to methods. What are the methods that I can apply on lists? So simple thing I can do is I can find length. For that I should use the function of the method len. That I need to pass the name of the list as argument within the braces. Let us see. It says the length of my list is 7. Where did this 7 come from? It's nothing but the number of elements that are available within my list. 4, 5, 6, and 7. So my list has 7 elements within it. So it has printed 7. Similarly, we can also find the length of names. How many names did you store in the names list? 4. So the output would be 4. And only that, and you can also in program you can print the length. Let me show you for this. It is also 4. So if you are going to write the same code in a Python program file with extension py, directly len names, all these things won't work, right? So you have to use print function explicitly and pass length of names as argument to print. Okay, so what does the length of empty list equal to? Empty list, you know, empty list is what we have already explored, and you have seen it has printed it this way when you ask to print the empty list. But what if I ask to print the length of empty list? It's nothing but 0, because empty list doesn't have any elements within it. What if I ask for length of like this? This is also an empty list, right? What I have asked is, what I have passed to length as argument is empty list. So it says there are no elements. What if I ask for print length of some list where I am creating on the fly and ask for this? It has 4 elements, no? So the length of this list is 4. And this list doesn't have any name because I did not assign this list to a list variable and then asked for length. This is anonymous list, it doesn't have any name, but the length function can directly go through this list and find its length. All good? Well, what if I ask for the length of has attended list? Has attended list. It is 5. As you see here, it has 1, 2, 3, 4, 5 elements within it. This is how length is a method that you can apply on lists. And length is a method that returns a number of elements that are present in a given list. Right? Now, you can also use sum as another function, and you can also pass some list to it. Just give you something like this. See, sum is another method that can be applied on lists. 12 is an element or the item within the list, and this is also anonymous list. 12 plus 23 is 35, 35 plus 10 is 45. That's what you see here. Similarly, I can also find the sum of what are the elements we have. My list is there, no? I can ask for the sum of my list. As you see here, it is again 38. 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 8, 18, 18 plus 9, 27, 27 plus 11 is 38. This is how sum is another method that you can directly apply on list to find out the sum of the elements within a given list. Sum of all the elements can be found using sum method. Similarly, you can ask for minimum. What is a minimum element within a given list? I put 8 here, and as you know, I can repeat the same elements within a list, right? So I'm repeating some of these elements intentionally, and you see it says that among all these values, among all these elements, among all these items, 8 is the one that is a list element. That's how min works, right? And I can also ask for minimum of my list. So look at it carefully. In my list, what is the smallest element? It is 1. So 1 is what it could be. Okay. And I can also ask for minimum of my data. Look at my data list. It has these elements. Some of them are integers. Some of them are one integer, one float, one boolean, one string. Sorry, two boolean, right? Now what happens if I ask for minimum within this? So as you see here, when your list has different types of data, min and max, these functions are not going to work. All right. So you should be careful about it. So let me also show you max, which works well for my list. Right. Maximum element within my list. My list is going to, okay, this is all my list, right? So in the my list, you have all these elements among which maximum is 11. So you could identify that. Similarly, you can also ask for maximum of, there is another list that has float values within it, right? Let's go back and figure it out. That is nothing but cost. So I'm going to ask what is a maximum of cost list. It says 123.54, and let's go and validate that. 123.54 among all these elements, yes, 123.54 is a highest number, biggest value, biggest element. So that is what it has given us. But what if I ask for maximum of my data? Remember, my data, my data is the, sorry, yeah, my data is a list which has mixed types of data, right? The elements belong to different types. So max is not going to work on such things, right? It doesn't know how to apply greater than symbol on str and float directly. So this is how we should be careful while applying such kind of functions on lists to make sure that the list doesn't have a data type on which Python doesn't directly know how to apply the comparison operator. Y greater than has come because you have used max function. So it has to look for maximum limit. When you have applied the same min function on the same list, it has reported about less than operator. It doesn't know how to apply less than operator on string type and boolean type, right? This is how you may face some errors when you're initially practicing, but you need to understand the reasons behind those errors so that you can rectify them. All right. So we have looked at the function length. We have looked at function sum. We also have looked at minimum, maximum, and you can also have average of um, my list. Sorry. Yeah. Um, doesn't know the average function If you want to really find the average, you can probably find the sum of my list, right? And then you can divide it with length of my list. This is how you can get this. And if you want to get integer part of it, you can use double slash integer division operator. Okay. All right. All right. So this is how you can find the minimum, maximum, sum, all that, right? Um, Now let me also show you. Okay, these are for now. These are couple of yes. We don't have AVG directly, as you can see here. So we have taken a different approach of finding the sum of the elements divided by the length of the list, which is nothing but the number of elements within that, right? So AVG is not a function or a method within Python. So all such things you have to just take a different approach to get your answer. All right, let's move on. So these are couple of methods that you can apply on lists. Okay, all right. So if you remember, how do I know what are all the functions that are available? One thing is you can do dir, sorry, dir on list, right? So you can see all of these, and whatever you see with underscore underscore, it means that those are the ones that are reserved or implemented by Python, okay, which are preceding with a double underscore and ending with a double underscore. Those are all implemented by Python within the compiler itself, right? So, and if you want to look at a couple of things, right? So, what is that we have really looked at, right? So I'll also talk about append, clear, and all these things. And one more thing is a count. What is count, right? So, but this is how you can get the documentation of any data structure. Here it is a list, and for example, now I'm going to show you what is count. Okay, so I have a list like this. You can create the list on the fly, as I said, right? Okay, you tell me how many ones are, sorry, how many ones are here in this list, right? So you can, so let me first show you how to know the dir of count function. Okay, you can say um, syntax of count function. Okay, what you can do is you can write, okay, sorry, 1 second, dir of list. Okay, so okay, um, okay. So if you look at dir of list, as you can see here, you got all these, right? And when it comes to count, what you can do is you can mention something like this. My list, for example, within my list, I want to understand how many times a particular element has occurred. That is what here the intention is. Let us go back to my list data. Okay, where is my list? Okay, my list has these values, right? I want to understand how many times 3 has occurred, and of course 3 has occurred only once, but I can count, right? So that is how count is used, and I can ask for that. So it says that count has occurred, three has occurred only one time with this my list. In other words, what we can also do is, if you want to really do it on the fly, you can also try this. Okay, this is a list dot count. You want to count for ones. So you see, one has occurred three times. This is how you can apply count method on this list. So you can have a list variable by yourselves, and then you can use that list variable and then dot count. And you need to pass one argument to count, which is nothing but what is the element you want to really count for within that given list. This is how these functions are used. Okay. And index and all these things, I'll come to these things later. And interestingly, sort is another function. So what if I have to sort a list? For example, it is my list only, right? Look at it. Um, Sorry, it's not this way. We should use my list dot sort, and I use print for that because you are not seeing anything as a result, right? So I can. So one way is to store the sorted value in that. See, this is the reason this sort function returns nothing, so you don't see anything printed over here. Then how do I know that the sorting has really worked, right? So what you can do is, I'll give you one example. I say list one is equal to, I have created a list here for you. Yes, okay, and I put some things over there. Okay, fine. Dot, I'll say sort. Okay, and now I print list one. Sorry. Sorry about that. I am not getting the. Okay, you can probably say help on sort. Here should be fine. So DIR of list. That's all. Yes. So within the list class, what are the methods you have? You can ask for the help of them, and you can um, you can get the all the supporting methods within that. Okay, so now let us get the sort function work for us. Okay, so um, all right, now I have list one. Okay, let me create one list. Okay, so I have the same, because sort returns none, that's the reason none is being stored in list one, is what we can figure out. So I'm just going to show you something like this. So this is list one, right? And if I want to sort it out, I can use something like this. Okay, and this works in I'll just print. The sort works in house, meaning you can see the elements are sorted. I have started with this list, right? Now you see all the elements have been sorted and they have been rearranged within the same list. So when you have to use sort, You create a list first and you call sort on that and then you print it, you'll see this. But this is ascending order. As you see, you start with smallest number and go to largest number. What if I have to sort this in descending order? For that, you can say list one is already now holding the values in ascending order. So you can say sort, and you can say reverse is equal to true. Generally, reverse would be false. Now, sorry, reverse is equal to true. No, sorry, two is what I have misspelled. T should be capital. No, list one dot sort reverse is equal to true. Right. All right. Now you can check list one, and you can see all the values have been sorted in descending order. All right. This is how we can sort the elements within the list. So as you can see here, we have looked at different methods that we can apply on list, including length, minimum, maximum, sum, count, sort. So these are all different types of methods that you can apply on lists. The next one is indexing, very interesting. Let us take another example. I have, say, overwrite my list. My list is equal to, I have some numbers. Let me go with, yeah, some random numbers, okay? I'll just take them unique so that I can easily explain you, okay? All right. Now, whenever you look at a list, right, these are the elements. I said position is important. Ordered list is what we said. These are the ordered elements. So I need to be in a position to understand what is the position of an element in a list, which is nothing but index. And if you really look at it, let me open a file and show you. Say for example, I have written something like my list is equal to some numbers. Don't worry about the numbers that I have used there, but this is something, right? So look at this carefully. What internally happens is there will be one index is what we call is allocated is automatically. You need not explicitly do this. Okay. And remember, Python is zero based indexing means always the index in such data structures start with zero. So 0 is index of element 12. 1 is index of element 34. 2 is index of item 32. 3 is index of item 45. 4 is index of element 12. Element or item both are one and same here, right? So this is how Python automatically assumes that 12 is positioned at index 0, 34 is positioned at index 1, 32 is positioned at index 2, 45 is positioned at index 3, and 12 finally is positioned at index 4. All right. Remember, this indexing, positive indexing starts from left to right. So the leftmost element within your list will have 0 as its index, right? And two consecutive indices will have a difference of one. That means the index will keep on increasing from left to right by one. All right. Now, how does this help? So one thing you can do is probably if you want to access 12, what you can say is, I just want to have not the entire list, but I just need to access just one element from that, which is at index 0. This is how I can do that. So you see index 0 within this. What is the element at index 0? Is nothing but 12. So you can see 12 printed over here. What if I ask for the element which is at index 4, right? 0, 1, 2, 3, 4. It is nothing but 18, right? So 0, 1, 2, 3, 4. It is 18. Oh, sorry, I did not use square brackets here. Sorry, my bad. Print. That is why it was treating it as a function call, but it's not function call. That is where it is. So list four. Okay, you see, it is 18. This is how, and you can also print anything here. You can access a random access is what we call this as. You can access any element within the list just by using indexing. So elements are indexed. Hmm? Python's list 0, 1, 2, and 2 is the element is 43 at index 2. So you can see 43 coming out over here. Right? This is called a positive indexing, and positive indexing starts with 0, and it again starts from leftmost element. It continues to grow by 1 um, in every subsequent position towards right. Interestingly, Python also supports negative indexing, and a negative indexing starts from rightmost element and it continues to reduce towards um, left. So this would be -3, this would be -4, this would become -5. Okay, all right. This is how you should assume this in your mind. So now, what is the element at index 0? It is 12. What is the element at index -5? That is also 12. What is the element at index -3? It is 32. What is the element at index 2? It is 32. What is the element at index -1? It is 12. What is the element at index 3? It is 45. So negative indexing is also allowed in Python, and this negative indexing always starts from rightmost element, and the smallest, sorry, largest negative indexing is -1 in Python, and with -1 it continues to keep reducing the indices towards left. All right, let us experiment that as well on my list. Print my list of -1. You see, it is nothing but the last element, rightmost element. So you can use negative indexing or positive indexing if you, while you want to refer to these elements. So this is again my list. Okay, -2. If you put -2, what happens? It is nothing but this is -1, no? So this becomes -2. So -3, -4, and -5. What if I ask to print the element at -5 to this? Is nothing but 12, the very first element, or which is also at 0 with the next element. What if I ask for some element which is at -10? Do you really have an element with index -10 in my list? Not really, because this is -1, -2, -3, -4, -5 is the smallest negative index. But you are asking for -2. Let us see what happens. This results into an error. To be more precise, this results into an index error because this index is out of range, right? It doesn't have this list, my list doesn't have an index -2. Not only for negative, this may happen with positive index also. So my list of how many elements do we have in total in my list? 5. So maximum index will be 4. I ask for 5 for example. Then also it is going to give you the same error. And I may ask to print 100. Do you really have an index 100 in this my list? Not really. So this also results into index error. So keep this in mind always whenever you are using index based access on lists. Make sure that the index that you are using is within the limits. Otherwise, it throws you an error. The index error is what you will face. All right, with this, we have completed indexing. The next one is very interesting, which is called slicing. Okay, let me print the values of my list one more time. All right, my list is just like this. It has 5 elements in it. Now, what is slicing? Slicing is nothing but extracting some portions of a list. Okay, slicing is nothing but extracting some portions of elements. So in this entire list, I have 5 elements. What if I need only first 3 elements, or last 2 elements, or middle 2 elements, or middle 3 elements? Okay, so this all comes under slicing. So this slicing has a syntax of some list. Okay, and within that list, you can mention start, you can mention colon, and you can also mention the stop. Here, start and stop are the indices. Okay, and this can be either negative indexing or positive indexing. So start and stop or indices. So let us see how this works here on the list, my list, right? So I am asking for my list. Okay, I want to get everything from 0 to, what if I write 3 here? Always remember this 0 is start and 3 is end. End index is exclusive. Exclusive meaning the element at index 3 is not counted for or is not included in your answer. So what this says is start with index 0. Okay, well, 12 is what we see at index 0, index 1, index 2, and stop there. Don't go to index 3 because 3 index 3 is exclusive. The end index is exclusive. So now you can see another list form. Whenever you apply slicing on a list, you will again get another list, right? So the difference between this list and this list is that this has lesser elements because you asked for limited number of elements, not the entire list. And of course, if you want to assign this to something, you can also assign it to some other list like this. So you can say my list, okay, you start from 0 and go up to, when you write 3, it goes up to second index 0, 1, 2. 3 elements is what it gives. Now, if you check what is there in list 2, you can see the same values coming out. All right. This is what slicing means, and there are different ways to slice a given list. One thing is you can just mention 0, 3. Let us see what happens. I did not mention the start value. If I don't mention the start values is always assumed to be 0. Hence, you can see the same output coming over here if I don't mention the start value. What if I ask for anything from second index? And what is the maximum index here? 0, 1, 2, 3, 4, right? 4. If I want to get last element also, I need to put 5 here because end index is exclusive. So when I ask for everything that starts with index 2 and ends with index 4, why did I say 4? Because 5 is exclusive. So the element at index 2, 3, and 4 is what I was asking. 0, 1, 2, 2, 3, and 4. This is what you can see here as coming out, right? And what if I don't mention the end index? For example, I say 2 colon. I don't really mention the end index. As you can see here, this also gives you the same answer. That means when you are slicing, you need to mention 2 indices, right? One is start index, the second one is end index. And if I don't mention the start index, it is implicitly taking It is going to take 0 as a starting index. If I don't mention the end index, it implicitly takes the maximum index plus 1, which is length of that list, as the value, default value. So if I ask for my list, start with 0 and go up to length of my list. See, I can write it like this. Yeah, you see, you get the same thing because you asked everything starting from 0 and length. Length is what here it is 5. You don't have an index value 5 as a valid index. However, this is exclusive, I said, so it continues to give me everything starting with index 0, 1, 2, 3, and 4, which results into 5 elements, and those 5 elements is what you see over here. With that, interestingly, what if I mention just like this? I don't pass start value, I don't pass the end value also, but I use colon here. What does it mean? So if I, since I did not pass start value is assumed to be 0, I did not pass the end value, and automatically it considers the length of the list as a end index. It means it gives me everything in the list. This is another way of printing all the elements within a list. All right. So this is what is called slicing. You can start at a given index, and here also in slicing also, what if I mention some index which is out of range? 2 is okay, but I asked it up to 10. You see, interestingly, when you use slicing, when the when here the end index is not even present in this list. However, it doesn't throw you an error. It will just take the minimum of the end value that you mentioned, or the end value, the length of the list is what it considers as a end value. So even if you ask for my list, okay, you may say I want everything from 2000. Do you have 1999 as a valid index in my list? Really not. But still, it doesn't throw out an error, but it will just limit the end value to the length of the list, and it produces everything starting from second index to the last element of the list. This is very important thing that you need to remember. In slicing, this is quite possible. And what if I ask for I ask for something from index 3 and index here the end value is 1. You will not get anything, right? Because end value should be greater than the start value, but it is not the case. So it just gives you empty list. This is how you can use slicing, right? You can use slicing, and in slicing, interestingly, say for example, you can also mention the step. How is that? My list of, you mention 2 colons, okay, and you mention 2 over here. Let's see what happens. You see, in the my list is this, right? You get 13, sorry, 12. After that, it skips 1 and it gives you, it considers 43. Again, it skips and it gives you 18. This is how you can skip the elements. You can also mention while slicing, you can tell, I need to get every alternative element, every second element is what you are saying. So it has considered the first element. After that, it omits one element. After that, it got 43. Since it has picked this, it omits this one and it takes this one. That is how you ask for step by 2, right? We can also ask for step 3. Can you guess what happens when you ask for step 3? It starts with 12. After that, it should go 10. It should give you 10. Why? This is what it has already considered. Then it needs third element from its next element. So one, two, third element is this. After that, it cannot go anymore because you reached the end of the list before you reach the next third element. So that is what you see here, and these are the elements that you see here. Make sense? Interestingly, let me print my list. These are the elements, right? And using this slicing, interestingly, what you can do is you can reverse the list. How is it possible? Let us see. You put -1 over here. What you are asking is give me all the elements within this list in reverse order, right? That's what happens, Here you asked for every third consecutive element. Here you are asking for just keep reducing by -1. That means you traverse backward is what you're asking. When you traverse backward in a list, all that you get is the reversed list. That is how you see this coming as exactly reversed list, right? This is how you can see, and this is a way to reverse a list using slicing. This is one important interview question. How do you reverse a string? How many different ways do you know to reverse a string? Right? So reverse a list. Okay. And slicing is definitely one of them that you can try it out. All right. Perfect. And this is about slicing on the lists. The next is membership operator. Another interesting thing. I'm going to explain that. Okay. Now that you know what are the elements in this list, these are the elements. I want to know if there is an element 12 available in this list. So you can just write like this 12 in my list. In is the operator. What it has written being is true. It always returns boolean. It means that 12 is available within my list. What if I ask is 11 in my list? No, 11 is not present in my list. So see how quite simple it is to know or to search whether a particular element is present in a list. It is just a single line of statement in Python. You need not write all the code on your own for this. However, some interviewers, just to test your knowledge, they may ask you to write the code on your own to understand to what extent you have the knowledge on these lists. Then you have to obviously write your own code. Otherwise, Python, the built-in capability of membership operator, which is in, will help you out easily with it. All right. So the membership operator in returns true if the element that you are asking for is present in the list, and if the element is not present, then it will return false. And similarly, you can also use not in front of in, not in my list. So 12 is already in my list. So 12 not in my list will give you false. Similarly, 11 not in my list. 11 in my list is false and 11 not in my list is true. This is how you can negate the membership operator and you can get the Boolean result accordingly. So this is called membership operator in Python and you can apply this on lists. With that, we have covered membership operator. The next one is concatenation. Interestingly, what is this concatenation? All right, let us have what is there in listing? Yes, these are the elements that I have in listing. Let me define another list. Okay, in this list I have 1, 9, 2, 3, and 8. Okay, and of course, let me add some more. Okay, this is what I see. List 1 is this. List 2 is this. Now, what if I use plus operator? Interestingly,